Section 8.5, Exponential and Logarithmic Equations. Exponential equation is an equation in the form of b to the cx equals a, where the exponent includes a variable. If m and n are positive and m equals n, then we know that the common log of m equals the common log of n. In other words, you can solve an exponential equation by taking the logarithm of both sides of that equation. Let's take a look at some examples. Solve each equation, round to the nearest 10,000ths. Here I have 3 to the 2x equals 80. What I want to do is take the log of both sides. So I'll have the common log of 3 to the 2x equals the common log of 80. Notice my bases are the same. They're both the common log base of 10. And what I'll do is use the power rule that we know from the previous section. That's going to give me 2x common log of 3 equals the log of 80. Now what I want to do is perform an operation that we've done many, many times in the past, which is inverse operation. 2 is multiplying my x, and the log of 3 is multiplying my x. So what I'm going to do is divide both sides by 2 log 3. And that's going to give me x equal to the log of 80 over 2 log of 3. Now I want to bring up my calculator and substitute those values in. So I'm going to have the log of 80 divided by, I'm going to put a parenthesis there, 2 log of 3, and then close it with an extra parenthesis. And that's going to give me approximately x equal to, and I need that to the 10,000ths position, tens, hundreds, thousands, 10,000ths, and I look to the right to make sure how I round. So the solution is approximately 1.9943. Now what I want to do is verify that my solution of 1.9943 is correct. So I'm going to substitute that value into my x, 3 to the 2x, and see that I have 80. So in the calculator I have 3 to the 2 times 1.9943, and when I calculate that I get 79.99, which approximates to 80. Let's take a look at another example. Here I have 8 to the negative 2 minus x equals 431. I'm going to take the common log of both sides, which gives me log 8 to the negative 2 minus x equals log of 431. I'm going to use the power rule, and this is my exponent, so I'm going to bring that out front, which is a negative 2 minus x log of 8 equals log of 431. The log of 8 is multiplying my quantity, so I'm going to divide both sides by the log of 8. That gives me a negative 2 minus x equals the log of 431 over the log of 8. Now I'm going to add 2 to both sides, which gives me a negative x equal the log of 431 over the log of 8, and I'm going to add 2 to both sides, which is plus 2. Now I'm going to multiply both sides by a negative 1. Therefore, x will equal a negative times the quantity of the log of 431 over the log of 8 plus 2. So what I can do is plug this quantity into the calculator and then just multiply it by a negative 1. and that will result in an approximation for x. So let's plug in our quantity. I'm going to have the log of 431 divided by the log of 8. I can calculate that value to be 2.91718. I'm going to add 2, and that gives me 4.91718. When I approximate that to the 10,000th position, it's 0.9171. We look to the right, it's an 8, so it's 0.9172. But recall, this is going to make that negative. Now what I can do is to verify my solution by substituting it back into the original problem. Therefore, that's going to give me 8 to the, and then I would put a parenthesis, negative 2 minus a negative 4.9172, which will be plus 4.9172, close the parenthesis, and I should approximate that to be 431. And you can see that I do. Therefore, my approximation is correct. In this example, I have 8 times the quantity of 4 to the 6 minus 2x plus 13 equals 41. I want to isolate the 4 to the 6 minus 2x. To do that, I'm going to subtract 13 on both sides first. That will leave me 8 times the quantity of 4 to the 6 minus 2x. And I'm going to subtract 13 on both sides. And when I do, that's going to give me 28. Now I'm going to divide by 8 on both sides. And that will isolate my base of 4 and its exponent of 6 minus 2x. And when I simplify on the right, that's going to give me, when I divide top and bottom by a 4, that's going to give me 7 halves. Now I want to take the log of both sides, the common log, which is going to give me common log of 4 to the 6 minus 2x equals the common log of 7 over 2. Using the power rule, I'm going to bring out my 6 minus 2x. I'm going to put that in a set of parentheses. 6 minus 2x, common log of 4 equals the common log of 7 over 2. Now I can see that my log of 4 is multiplying my quantity with the x in it. So I'm going to divide both sides by the common log of 4. And that's going to give me 6 minus 2x equals the common log of 7 over 2 over the common log of 4. Now I want to subtract 6 on both sides. Gives me a negative 2x equals the log of 7 over 2 over the log of 4. But remember, I subtracted 6 on both sides, minus 6. Now what I want to do is multiply both sides or divide both sides by either a negative half or divide by a negative 2. I'm going to multiply by a negative half. That's going to give me x equal to a negative 1/2 times the log of 7 over 2 over the log of 4 minus 6. And the whole right side is in the set of parentheses being multiplied by a negative half. Now this I can substitute into my calculator and figure out an approximation for x. That's going to give me, I'm going to put a lot of parentheses in to make sure that my order of operations is followed. Parenthesis, negative 1 divided by 2 I'm going to close that set of parentheses, put another set of parentheses down, and then I'm going to have the log of 7 divided by 2, close that set of parentheses. I'm going to divide by the log of 4, and then close that set of parentheses. And then what I'm going to do is subtract 6, and then close the set of parentheses after that. And then I hit enter, and my approximation is 2.5481. I'm going to round to the 10,000th position, which will give me 2.5482. Now I'm going to substitute that value back in, hit enter, and then I'm going to add 13. And you can see I get 40.99699, which will approximate to 41. In this example, I want to solve my equation by graphing. Here I have the exponential equation 3 to the 4x equals 421. In my y-editor on the calculator, in y1, I'm going to place y equals 3 to the 4x. In y2, I'm going to graph the horizontal line y equals 421. When I bring up my calculator, you can see I've already done that. I have, in y1, 3 to the 4x, and in y2, 421. If I graph that function, I won't be able to see much because I'm in zoom 6. And I need a value that's on my y-axis at 421. So I'm going to go to my window, edit my x min to be a -1, because I don't need to be on the quadrants of 3 and 4. And I'm going to go to my y min for 100. And my y max, I'm going to put at 430. That'll give me a good open space to see 421. My scale will divide into the difference between that, which is 30, and I'm going to put a scale of 3, and then I'll graph. I should see my exponential function and my horizontal line. What I want to do is to find my intersection point. So I'm going to hit second, calculate, and number 5, which is my intersection point. So it asks me, the first curve is y equals 3 to the 4x, enter. My second curve is y equals 421, enter. And it should give me an approximation for x to be 1.3751. Of course, I can substitute back in to verify that. 3 to the 4 times 1.3751. As you can see, my approximation turns out to be 421.0733, and therefore that approximates to 451. So this is the correct solution. In this example, I want to use a table to solve each equation. On the past slides, we've learned how to solve these equations by logarithms, and we've also solved them by graphing two equations and finding their intersection point. This is a third method that I don't find as exact, but it's a good way to look at a change in positive negative signs to find out where a 0 lies. So let's begin by setting the equation equal to 0. That's going to give me 5 to the 2x plus 1 minus 10x minus 8 equals 0. Now I want to graph using the y-editor in your calculator. I've already done that. I've entered this equation into my y-editor. Now what I want to do is to graph that function. As you can see, this is not a good view. So the third thing it says is to change the window for better viewing. We've done this many times. You can see that my intersection point is going to lie somewhere between a -1 from my first one and 0, and the other one's very close to 0 itself. So when I go to window, I know that I can shrink my x values down to about a -3 for the min and a +3 for the max. Now I can graph that again, and I can get a better view. As you can see, I'm going to fall in between -1 and 0 for my first solution, and again between 0 and 1 for my second one. Now what it says to do is to trace to find the sign change for y values. And what I mean a sign change is a positive to a negative on the y value. And in between a positive and negative is going to be a 0. So let's trace and we'll see. So let's go to the first one. Let's go to the one on the right. And as you can see, I have an x value of 0.19148 and a y value of a negative 0.6538. If I go one more above, that changes in between a positive and negative. Actually, I'm closer with the negative 0.6538. So I'm going to drag that over so we can keep that window. Now let's trace again. And what I want to do is go to my other intersection point of the x-axis, my x-intercept. I'm still negative on my y value here. And now it changed to positive. So you can see I went from a negative to positive value, and there's a 0 in between there. So let's drag that over here. And now I have two values that I need to find that are going to solve this equation. So now what I want to do is go to number 5 is edit your table set and view your table. So we're going to hit second window, and that's my table set. Now my first one, I want to start at an x value at 0.191. And let's take my table change, which is that's delta table. That means my values are going to change at each point that value. I'm going to point 0.001. Now I'm going to hit my table, which is second graph. And you can see that I'm getting smaller as I go down. I'm getting closer to my 0 on my y value. I'm looking for a negative change to a positive. And I just hit it right here. So I have a sign change between negative 0.0033 and 0.0196. So my solution is right around 0.22. And that would be for this point on the graph. I want to go back into my calculator and find a table set near negative 0.765. So second table set, and I'm going to have a negative 0.765. I'll keep this value the same. I'll hit second table. And you can see I have all positive values here. I want to get to a table change in my y values. And there it is. I have negative 0.757 and negative 0.756. So my value is at a negative 0.75. So my two solutions for my problem are going to be here at 0.22 and here at 0.75, a negative 0.75. Of course, we could verify that better by going to second, calculate, and actually finding our 0, but I'll leave that up to you.